Hey everyone, welcome to The Explainer. Today, we're literally looking up. We're going to break down the actual physical and chemical processes that are fundamentally altering our planet's atmosphere right above our heads. It's a fascinating, deeply important subject, and I am so excited to unpack the science behind it with you. So, let's dive right in.
Here is our roadmap for this explainer. 1. The greenhouse effect explained. 2. Natural versus artificial greenhouses. 3. Consequences of trapped heat. 4. Decreasing the greenhouse effect. And finally, 5. The acid rain phenomenon.
All right, part 1. The greenhouse effect explained.
Okay, quick question for you. Have you ever stepped outside on a cloudy night and thought, wow, it actually feels way hotter tonight than when the sky is totally clear and full of stars? Because, well, it is. And that relatable everyday feeling, that is the absolutely perfect way to wrap our heads around the concept of trapped heat. Those clouds are basically acting like a giant, cozy blanket, keeping the Earth's warmth right here with us instead of letting it escape out into space.
So, formally speaking, the greenhouse effect is simply the process of trapping solar energy inside a greenhouse, which naturally bumps up the temperature inside. You've probably seen this yourself, right? Like walking into one of those long plastic tunnels at a farm or inside a massive glass botanical garden. It's actually a brilliant, super basic trick of physics.
Let's look at the physics here. Short solar waves travel all the way from the sun, and they just zip right through the transparent glass or plastic. Easy. But, and here's the catch, once that solar energy hits the ground and the plants inside, it's absorbed and then radiated back out as heat energy. But this new heat energy, it travels in long wavelengths. And those long waves simply cannot escape back through the glass. No way. The heat is literally trapped, and the temperature inside just keeps steadily ticking up. Now, before we get into the heavy stuff, we've got to acknowledge that on a micro scale, this heat-trapping mechanism is incredibly useful. Think about it. By artificially controlling this environment, we can grow summer tomatoes in the dead of winter. We can protect rare or even near-extinct plants from freezing over. And from an agricultural side, it lets farmers grow unseasonal veggies for profit all year round. It's a highly effective tool.
Moving right along to Section 2, Natural versus Artificial Greenhouses. So there's a really fascinating duality we're dealing with here. In an artificial greenhouse, the physical barrier is just transparent glass or plastic. But zoom out to the entire Earth, and it acts as its own natural greenhouse. Instead of glass, we're wrapped in a thick atmosphere of gases. And these gases do the exact same job. They let the sun's solar radiation fly right in to warm the surface, but they stop a huge chunk of that reflection from bouncing back out into the void of space.
So, what exactly is this planetary glass made of? Well, this invisible ceiling consists of very specific greenhouse gases. We're talking carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, or CFCs, ozone, and even everyday water vapor. Together, these form the barrier that catches that solar radiation and sends it right back down to us.
And here is a point I absolutely want to stress. The greenhouse effect is not inherently some bad, evil thing. Actually, scratch that. It's a lifesaver. It is a perfect Goldilocks balance. Without these naturally occurring gases, Earth's temperature would be so violently cold that life simply couldn't exist, period. It's a life-giving blanket. The problem isn't the effect itself. The problem is that human activities are currently throwing this whole delicate system completely out of whack.
Which brings us to Section 3, Consequences of Trapped Heat.
All right, so on one hand, you have a beautifully balanced natural ecosystem. On the other, you have a heavily polluted, overheating planet. Because of human activities, mainly rapid industrialization and pollution, that layer of greenhouse gases is getting thicker and thicker. Because it's thicker, even more radiation gets forcefully reflected back down to Earth, completely trapped. We are basically slapping double-paned glass onto our global greenhouse, and as a result, the temperature is just spiking abnormally.
And guys, the consequences of this abnormal heating are severe, and they are everywhere. We're talking about the rapid melting of snow in the Himalayas and massive glaciers, which, of course, directly leads to sea levels rising, threatening to literally flood coastal regions all over the globe. We're also seeing the entire global water cycle get disrupted, causing aggressive desertification in some areas. It's a massive domino effect, degrading our biodiversity, hurting agricultural productivity, and ultimately having huge negative impacts on human health. We're talking about a real macro-level crisis here.
Okay, Section 4, Decreasing the Greenhouse Effect. So how do we fix this? To decrease the greenhouse effect, we absolutely have to rein in the production and use of these gases. The source material outlines 5 clear, actionable steps.
Number 1, a full, absolute ban on the production and use of CFCs. 2, a serious, steep decrease in how much petroleum and coal we burn. 3, we need to heavily promote alternative energy, things like hydro, wind, and solar. 4, simply planting way more trees to naturally suck up that carbon. And 5, a broad, overarching push to just reduce our overall production of carbon dioxide. These steps are absolutely crucial to hitting the brakes on that atmospheric imbalance we just talked about.
And finally, Section 5, the acid rain phenomenon. Now, you might be thinking, okay, so it gets hotter. But greenhouse gases aren't just trapping heat, they're actually cooking up a highly toxic secondary crisis above our heads. See, normal rainwater is already a little bit acidic, usually sitting right around a pH of 6. But when we talk about acid rain, we're looking at a dangerous pH drop, plummeting down to anywhere from 3 to 5. And this severe phenomenon isn't exactly a new discovery. It was actually first confirmed way back in 1960. But how exactly does rain turn into acid? Well, it's essentially a toxic recipe brewing in the clouds. Sulfur dioxide, which gets pumped out by industries and vehicles, mixes with atmospheric water to form literal sulfuric acid. Carbon dioxide mixes with water to form carbonic acid. And nitrous oxide and chlorine, they mix with water vapor to become nitric and hydrochloric acids. These aren't just abstract chemical equations you'd see on a whiteboard. This is the exact, literal process of how everyday industrial exhaust turns the very rain that waters our crops into falling acid.
And the reach of this acid rain is, frankly, devastating. When it hits the ground, it spikes the acidity of the soil, which drastically tanks agricultural productivity. It mixes straight into our lakes and rivers, doing severe harm to aquatic life. It's got direct, nasty health effects on us humans, including triggering skin diseases. And structurally, it literally eats away and fades monuments, temples, and entire buildings made out of stone and marble.
It's wild to realize that acid rain is slowly, chemically erasing beautiful, historic structures day by day. The calcium carbonate inside the marble and stone reacts directly with the sulfuric acid in the rain, basically melting it. It takes all that abstract atmospheric chemistry we've been talking about and turns it into a highly visible, honestly heartbreaking reality right before our very eyes. So, from the helpful, controlled warmth of a plastic botanical greenhouse to the destructive, unchecked power of acid rain eating away at ancient stone monuments, our atmosphere is an incredibly delicate, highly reactive system. As human activity continues to alter the very chemistry of our sky, we really have to ask ourselves, what steps must we take today to protect the fragile, Goldilocks balance of our one and only natural greenhouse? Thank you so much for joining me for this explainer. Keep asking those big questions and keep learning.